Harry from GMAT Ninja here, and in today's video we're going to be talking about word problems on the GMAT. Now there's no content involved in this. We're not going to be showing you some new way of doing algebra here. This is all about how do you translate from text to algebra, get that first equation set up, and then we can work through the rest of the problem. Now this is a hugely important skill on the GMAT. In the current version, if we compare it to the old versions of the GMAT, there are more word problems. The word problems tend to be longer, and the skills we're going to talk about today are really helpful for the quant section, but also parts of the data insight section, whether that's data sufficiency, or we could even talk about some of the two-part analysis questions here. So this is a very broad skill that's going to apply across a lot of the GMAT. So with that, I've got 6 questions for you today. We're going to start out relatively easy, possibly around the 75 level. First 3 questions are not going to be that tough. Questions 4 and 5, hopefully we're going to turn the difficulty level up just a little bit and get you a bit of a challenge once we get to question 6. But really, the questions in this video are not designed to be that challenging. It's just more about developing those skills, what to look for and how do you translate from text to algebra. Now with that, in these 6 questions, I've got 2 data sufficiency questions for you. We know data sufficiency has moved across to the data insight section, but the content and the skills involved in these are very similar, so we're putting a couple of questions in this video as well. Now, having said that, I'm going to get the first question on the screen, take a couple of minutes, have a look at this, and I'll see you back here to go through the solution soon.
Hey everybody, Charles here. Sorry for the interruption. Before we get you back to that quant content, 3 quick things I'd love for you to be aware of. First of all, this video is part of our full, free, complete GMAT course that's available up on our YouTube channel. If this course is saving you money that you would otherwise spend on a course or a tutor, please consider donating some of that savings to charity, either a charity that you love. If you don't have a charity that you love, we've got a list of charities that we love to support on our website, gmatninja.com. Second thing, if you love that presenter that you're watching in this video, not me, the other one, they offer one-on-one tutoring. If you're interested in that, gmatninja.com and we can set you up. Third thing, finally, if you're doing great on the GMAT, doing great on the GRE, starting to look for admissions help with your applications for grad school, we would love to refer you to a bunch of our favorite companies. So just hit us up. There is a contact form on our website, gmatninja.com. Also, a link in the video description. Just fill that out. We'll send you a list of our favorite admissions consultants, not just at our company, no strings attached, not gonna sell your email, not gonna try to sell you anything. We just wanna make sure if you've put in the hard work on the GMAT, that you end up in the best possible hands if you need help with your applications. All right, that's it. Enjoy the quant.
Okay, hopefully that was enough time to take a look at question 1. Look, as always in these videos, if you ever need a bit more time, feel free to pause here, go back to the question. We'll still be here whenever you're ready to take a look at the solution. All right, so question 1, hopefully that wasn't too much of a challenge. It wasn't meant to be. We're using some easier questions to go through the principles, the processes, the things we want to talk about in this video. All right, so with that, if this was the only question you watched, and if this was the only part of the video that you took anything away from, there are two things that I really want you to focus on when we're doing these questions. The first is, what I want you to think about is define your variables very clearly as early in the question as you possibly can, and then don't let that change as you work through the question. We'll get into this one and I'll show you what I mean by that. I'm going to do this one in two different ways. This sort of question, there are loads of different ways of doing it. I'm going to show you two. If you've got another method, feel free to punch it in the comments. It'd be great to see some other ways of doing it, but let's take a look at what we can find here. All right, so the scenario I've got is Annika and Badger are different ages, and we've got different ways of comparing them, and I want to know what will the sum of their ages be in 5 years. Right, now first thing I'm going to do is define my variables. Annika's age we're going to talk about as A, and Badger's age we're going to talk about as B. But I'm going to be a bit more clear than that. It's not just Annika's age. I'm going to talk about Annika's age now, and B is going to be Badger's age now. Now that's going to make a difference as we move through this question. So if we take a look at the first line of the question here, so Annika is 18 years older than Badger, that's talking about the difference in their ages right now, in the current day, and we can use A and B here to say, well, A is just equal to B plus 18. Annika is 18 years older than Badger. Great, that no problem. All right, where this becomes important is when we look at the second line here, when we're talking about what happens in 5 years. So in 5 years' time, Annika is going to be 3 times as old as Badger. I can't just say that A equals 3B, because A and B are their ages now, not their ages in 5 years' time. In 5 years' time, Annika is going to be A plus 5 years old, and Badger is going to be B plus 5 years old. Well, now that I've got these set up in 5 years' time, I can say that Annika's age in 5 years' time will be 3 times what Badger's age in 5 years' time is, and I can get this second equation, A plus 5 is equal to 3, B plus 5. Now from here, I've got the two equations, and this is sort of the translation from text to algebra part of this question done. From here, it's just a case of going to solve this set of simultaneous linear equations, and we can go and do that now. Taking this second one, I'm going to simplify it a bit. A plus 5 is equal to 3b plus 15, so A is equal to 3b plus 10. Here I've got two equations that both have A equal something, so I'm going to push them together and say B plus 18 is equal to 3b plus 10. So B plus 18 is equal to 3b plus 10. That means that 8 is equal to 2b, so I can say B is equal to 4. I can then take this, B is equal to 4, put it back into the top equation and say that A is equal to 18 plus 4, that's 22. Now great, this is where we need to be careful, because the question said what will the sum of their ages be in 5 years. I've got their ages now. So adding 5 to both of these, Badger's age in 5 years will be 9, Annika's age in 5 years will be 27, and to get to the final answer I do 27 plus 9, that'll give me 36, so the answer here is C. So like I said, I've been very clear about what the variables are, the first thing I do in the question, and then be very careful about sticking with them right the way to the end. I'd be willing to bet that a few people have got down to A and B here and just gone, okay, those are their ages, let me add those together, gone for 26 and chosen A as the answer. Whereas because we've been careful enough to say this is their ages now, and the question will be what will the sum of their ages be in 5 years, I've known to add 5 to each of their ages, got the answer as 36, and not slipped up on a question that really we should be able to answer. All right, I said that I'd give you two ways of answering it. This one, we defined A and B as their ages now. Well, what we could have done is defined their ages in 5 years. So A is Annika's age in 5 years, and B is now going to be Badger's age in 5 years. And we can do the same process. Well, let's work our way through the question. So top line of the question, Annika is 18 years older than Badger. Now this is the bit where we need to be careful. Because I've defined A and B as their ages in 5 years, if we work back to now, well then we're going to need to say something like A minus 5 to translate Annika's age in 5 years back to Annika's age now. So Annika is 18 years older than Badger's age now. So A minus 5, Annika's age now, is equal to Badger's age now, B minus 5 plus 18. And again, we can take this equation and simplify it. And so I actually end up with something equivalent. Now, second part of this, in 5 years, well, that's A and B. We've already got those set up. Anik will be 3 times as old as Badsha. And so I can just say A is equal to 3B. And I've got 2 equations. And then I can go and solve them. We're going to get down to the same answer because this is the same question. But this is just to show you that there are plenty of different ways through these problems, but it all depends how you define your variables. As long as you're clear about that early in the question and then you stick to those definitions as you go through the problem, you should be fine. The actual algebra in these problems is not going to be that tough. The challenge is about getting that first line of algebra down on paper. All right, hopefully that was a relatively easy way into this video. We're gonna get the second question up on the screen, take a couple of minutes and have a look at this. Okay, a lot of text in this one, and really that's the challenge here. It's not so much the algebra that we're going to see at the back end, it's just that intimidation factor of opening up the question, just seeing this wall of text hit you. So hopefully you manage to stay calm, and really that's the challenge here. Just keep reading. Hopefully we'll be able to pull out the algebra that we need from the text of the question and then just go from there. So let's jump in and see what we're told. So we've got this formula for the salary of an employee, and really let's just take a look at the last bit of the question. So the question we're asking, according to this formula, how much greater is Thomas's salary than Sylvan's? So let's figure out what the formula should be first, and that's this middle sentence. So we're looking for the sum of 12 times the number of years that employee has worked at the company and 45. So the sum of the number of years times 12 plus 45. So we could say the salary of somebody 12 times the number of years that person has worked at this company plus 45. And what the question is asking us for is, Thomas's salary minus Sylvan's salary. Now we can put some figures into this. We can say that Thomas's salary, if I change y out for t, so t is going to be the number of years that Thomas has worked at the company. Again, being very careful with my variable definition. So that would be 12t plus 45. There's Thomas's salary. And from that, I'm going to subtract Sylvan's salary, and that would be 12s plus 45. All right, so we can do a bit of pushing the question here. We can take this further, simplify the algebra a bit. If I just say that's 12t plus 45 minus 12s minus 45, the 45s are going to cancel, and I'm left with 12t minus 12s. Now, I'll come over here. This is equivalent to 12t minus s. And so that would be if I push the algebra as far as I can, that's what we're trying to ask here. But this is a data sufficiency question. It's not really what is the difference, it's can I tell the difference? And so while this is not algebraically equivalent, it's logically equivalent to say if I know what t minus s is, then I'll just be able to tell the difference. Because if I know what t minus s is, I can just times it by 12 and that will give me the difference between their salaries. So as long as I know the difference between the number of years that they have worked at this company, I'm going to be able to tell the difference in their salaries. All right, so we've taken this question as far as we possibly can. We know what we're being asked it for. Let's get into number 1 and statement 1 and statement 2 and see where this question goes. And I'll stick the AD over BCE up here so that we can guide ourselves through the question. So statement 1 tells us Thomas has worked at the company 6 years longer than Sylvan. So we could say that T is equal to S plus 6. Thomas has worked at the company 6 years longer than Sylvan. Well, with a bit of rearranging, I can say that T minus S is equal to 6, which is exactly the thing that we just said that we were looking for. And so we're basically there. Statement 1 is going to be sufficient here. So I'll cross out BCE, and the answer to this can either be A or D. All right, statement 2, Thomas has worked at the company 3 times longer than Sylvan has. Now this tells me that T is equal to 3S. Now I can do a few things with this. I could take this, really the thing that we're looking for is what is T minus S. Well, if T is equal to 3S, I could say that T minus S is equal to 3S minus S, that's equal to 2S, but I'm not going to be able to get a number out of this. I'm not going to be able to tell what S is or T is from this. I could substitute the other way, it's still not really going to get me anywhere. Knowing that Thomas has worked at the company 3 times longer than Sylvan has is nice, but isn't actually helpful for what I'm trying to do and answer this question. It's not going to get me towards an answer. So here I can cross out D. Answer to this question is going to be A. And as you can see, a lot of this came from pushing this question as far as we could. Once we got into statement 1 and statement 2, there really wasn't all that much work to do. This was just all about not panicking when I see that huge wall of text up at the top. There's only one equation we can really pull out of it. Then we can do a little bit of algebra to sort the question out, and from there hopefully things start rolling. So word problems, one of the other things we can say is, yeah, they might look big, they might look scary, but just take your time. Hopefully the algebra that you can pull out of them isn't going to be that tough. All right, we'll get the next question up on the screen, take a couple of minutes and have a look at this. Okay, back to problem solving with question 3, and we've got an equation to set up here. Now, one of the things you can do if you're struggling to figure out what should go on each side of the equation is to think about the scenario that we've been given. There's only so many things that we can make equal to the other side, and you can also think about the units of what you're putting on each side of the equation. So in this, we're trying to make a series of sales. over a course of weeks. We can't set weeks equals to sales. That doesn't make sense. We're going to have to set something like weeks equal to weeks, sales in a week equal to sales in a week, or total sales equal to total sales. And with the question, only one of them's really going to make sense here. We can't really set number of weeks equal to number of weeks because we don't have anything we can work with. And that's the question. That's what we're going to try and get to. We can't really set sales in a week equal to sales in a week because which week? We don't really know what's going on here. What we can do is we could put total sales equal to total sales. We know this sales team's trying to make a quota, and we've been given information about two different plans. Well, they had a plan, the plan's not going well, they need to change the plan. So two different ways of reaching that quota. I don't know what the quota is, but once we know the number of weeks, we'd be able to figure it out. I don't really care, but at least we can set that total number of sales that they're trying to make initially equal to the total number of sales they're going to make under the new plan. And then we've got an equation, total sales equals total sales, and from there it's just a case of filling in the gaps. So back to the scenario here, we've got a team, they plan to make 700 sales each week, and if they had made 700 sales each week, they'd have hit their quota. So that's going to give us one side of this equation. Okay, defining my variables, I'm going to say W is equal to the number of weeks this team had to make their quota, which means one side of my equation is just going to be 700 multiplied by W. If they had made 700 sales each week for the total number of weeks they had to work with, great, we're there, and there's one side of the equation. On the other side, okay, the plan's not going well. They made 550 sales per week so far, and now have 3 weeks to close the final 4,200 sales. So they've been making 550 sales per week for a number of weeks that's less than W. We're not going to use W again. They have 3 weeks to make the final sales, so up till now, 550 sales per week for W minus 3 weeks. 3 weeks fewer than the total number of weeks they had to work with. And so in those final 3 weeks, they need to make 4,200 sales. And there we go. Now we've got our equation, and from here on out, hopefully this is not going to be that bad. The challenge with this question was getting that equation out there, and from here it's just a case of solving this equation. So left-hand side doesn't change for now, but let's expand this set of parentheses. 550 times 3 is going to be 1,650. We've got 4,200 on the end. Subtract 550 from both sides. I'm going to get 150 multiplied by W is equal to 2,550 on that side. Divide both sides by 10. I've got 15W is equal to 255. Dividing by 15. Now, if you can see this in one go, fantastic, let's go after it. What we could do here is say, well, I don't want to do that in one jump. Let's divide by, I know 15 divides by 3, it divides by 5. Let's divide both of these by 5 first and see what we get. So 255 divided by 5, that's going to give me 51, and I'm over divided by 3, and then 51 divided by 3 is going to give me 17, which means the answer to this question is going to be B. All right, so a couple of things there. First bit, as we said at the start, look, if you're not sure about what you can put on each side of the equation, just have a think about the situation you've been given and think about what would it make sense. I need something to be equal to something else. The units have to match up, and we have to be able to figure out what goes on each side of the equation from the scenario we've been given. In this case, it made sense to think about the total number of sales that would help this team reach their quota, because we've got the two different plans for how they're going to do it. Once we got that first line of the equation, great, then it's just a case of going to solve it. But just down here, I know this is not the arithmetic video, but you don't have to do, if this is a big nasty calculation, you don't have to do big nasty calculations in a single step. Think about how you could break it down, make the calculation smaller. Let's just make things easier for ourselves, try not to make any errors. All right, so first 3 questions have hopefully been not too tough. We're going to start to turn the difficulty level up a little bit now. As I say, this is more just about the skill of translating from text to algebra. So we'll get the next question up on the screen, and we'll give you a couple of minutes to take a look at this one. All right, we said we were going to make things a little more difficult and give you another great big wall of text to work your way through. Again, hopefully you've taken the stuff that we've done so far and broken this problem down, been careful with your variables, all those other things, and arrived at, hey, the algebra is a little bit more difficult here than it has been in the previous questions, but arrived at something that you can at least work with. So let's jump in. We'll take a look at this huge wall of text and see what we can make of it. So I'm just going to work through this bit by bit. So we're told that to rent a yacht for a day costs a total of $D. So we've got a cost for this yacht. And then a group of F friends on a spring break initially agreed to share equally the cost of renting the yacht for a day. So we could say that the total cost, that's going to be D, and then the cost per person, we divide that D by F. So initially, at the start of this situation, the cost per person is going to be D over F. But then we get told that G of the friends partied too much the day before and couldn't make the trip. So now, number of people on the trip, well, that's going to be, we've lost G people. It's going to be F minus G. Now, we're going to be careful here. The question didn't say that G people were now going on the trip. It's just G people are not going on the trip. So the total number of people on the trip is now F minus G. I don't know what F and G are, but it's going to be F minus G. All right. And then which of the following represents the additional amount in dollars that each of the friends went on a trip would have to contribute so the cost of the rental is completely paid. So we've lost a few people, but there are still F minus G people who want to go. So the cost per person after we've lost these G people is going to be D, the total cost of the yacht, divided by the number of people who went on the trip. Now, presumably this cost is going to be larger than the cost originally. We've lost some people, so the people who are going on the trip are going to have to pay a bit more. But I want to know that the additional amount. In other words, the difference between what they initially thought they were going to pay and what they ended up paying. Now this is going to be bigger. D over F minus G is going to be bigger than the top of the fraction. The numerator is the same. We've made the denominator of the fraction smaller, so the overall fraction is going to be bigger. So D over F minus G is going to be bigger than D over F. So the additional amount they have to pay is going to be given by D over F minus G, take away D over F. And there we go. We've got our first equation. Well, we've got the thing that we want to find written out there, broke the question down, built it up step by step, and now that we're here, I just need to simplify this. Really, given how the answer choices are set up, I need to turn this into a single fraction by doing that subtraction, and then we're going to be able to see which of the answer choices is our final answer. So taking this and giving each of them a common denominator, so I'm going to take the first fraction and multiply top and bottom by F, and take the second fraction and multiply top and bottom by F minus G. I can then put these together into a single fraction. So I've got df minus, and I'll expand that set of parentheses, df plus fg. The df's are going to cancel, and I end up with, sorry, that should be dg. I end up with dg over f minus g. Looking across at the answer choices, that matches D, and so the answer to this question is going to be D. All right, so like I said, the algebra got a little bit more complicated there. I took my time, worked through the question sentence by sentence, built up the variables, built up the things I need. Eventually we get that first line of algebra, and from there these questions should be hopefully relatively simple to get to the solution. All right. As I say, we're sort of turning the difficulty level up just a little bit. Get the next question up on the screen, take a look at it. I'll see you back here to go through the solution soon. Okay, things should be starting to get a bit more difficult here. And one of the ways that GMAT can do it, and it's what we've done here, is to add in a special symbol into the question. So that first sentence here, we get told that this x inside this sort of special squiggly set of parentheses, that denotes the smallest integer greater than or equal to x. Now, one of the things you can do whenever the GMAT throws a new symbol is let's just chuck some numbers in and see what this symbol does so that we can see how we use it in a question. So let's say something like if I put 1.7 inside that set of brackets, well, what comes out of that is the smallest integer greater than or equal to x. So the smallest whole number that is bigger than or equal to 1.7, well, that's going to be 2. Picking some other numbers, if I just put 1 in there, the smallest whole number that is greater than or equal to 1, well, it's going to be equal to 1 is 1. The smallest whole number greater than or equal to 1 is just 1. Keep going. If I put 0.4 in there, well, the smallest whole number that's bigger than or equal to 0.4 is just going to be 1 again. And now, just so I'm sure, let's put negative 0.4 in there. Because I'm not just making the number bigger, I need to think about moving right along the number line. The smallest integer greater than is going to be to the right of the number line. The smallest whole number greater than negative 0.4 is going to be 0. Okay, so once you've got an idea about what that new symbol does, we can try and apply it to this question. So we've got this whole scenario about the video editing film. It's charging money for filming certain lengths of film. And in the question, it's broken down into 15-minute chunks, but we've got a film that has a length of p hours. Hours versus 15 minutes, there's going to be some level of difficulty in there. So again, just to get a sense of the question, let's just throw some numbers in here. So to begin with, I'm going to say what happens if p is 2.3 hours. Now we can break this down first. 2.3 hours is 2 full hours. We're going to have a quarter of an hour plus a little bit, so 0.05 of an hour. And by 0.3, I don't mean 3 minutes, I mean 0.3, so 3/10 of an hour there. Now we're dealing with 15-minute chunks here, so 2 hours, that's 8 blocks of 15 minutes. 15 minutes, quarter of an hour, so 2 hours is 8 blocks of 15 minutes. I've got another quarter of an hour here, that's another 1 block of 15 minutes. And 0.05 of an hour, even though that's not a 15 minutes, we were told that this company would charge $20 for editing each additional 15 minutes of film or length of film up to 15 minutes. So even though this is not a full 15 minutes, the company will still charge as if that block is 15 minutes. And so I've got 8 plus 1 plus 1, I have a total of 10 blocks that we need to charge for. So the question really becomes, I've got hours, we're charging in blocks of 15 minutes, so I need to at some point multiply p by 4. The question is, do I do that outside of this special symbol or do I do it inside? Well, let's try it outside first. So if I do 4 times 2.3, well, what's inside that set of parentheses, that's going to be rounded up to the nearest whole number. That means we're going to get 4 times 3, we're going to get 12 blocks, which is not what I'm looking for. I'm looking for 10. Okay, let's try putting it inside that special symbol. So 4 times 2.3. Well, 4 times 2.3 is 9.2. And then the smallest integer greater than or equal to 9.2 is going to be 10, which is what I'm after. So in the formula I'm going to come up with, I want to have the 4 inside the special brackets along with the p. Now each of those chunks of time, that's going to be charged $20, so I can start to build this up. I'm going to have 20 multiplied by 4p, and that's going to tell me the amount that this film company is going to charge. But then we were told at the start they're going to charge $140 for editing the first 15 minutes of a film. So the first 15 minutes is a bit special here. So I need to add on 140, but being careful, I've actually, in this formula, I've counted that first 15 minutes twice because I've built it into this 4p. P is just the total time of the film. It includes that first 15 minutes. So I'm charging $20 for that first 15 minutes, but then I'm also charging for the first 15 minutes in that initial $140. So in order to make this work, I need to take away $20 that I've included in this bit. And that will mean that I've only counted that first 15 minutes twice. We get charged $140 for the first 15 minutes. I'm then going to be charged $20 for everything else. But because I've counted that first 15 minutes in here, I need to take away $20 in order to make this thing work. So simplifying the whole thing, and because the answer choices have the number first, 140 minus 20 will be 120 plus 20 multiplied by 4p inside this special symbol, which means the answer to this question is going to be D. Right, so yeah, when the GMAT, if the GMAT does throw one of these special symbols at you, yeah, feel free, take a few seconds, throw some numbers in, just make sure you understand how it works before you see how it applies to the question. As you can see here, the actual work, the actual algebra that I had to do was really just constructing this. There was a single line to get to the answer from there. So if you're getting to this stage, I mean, we've got 2 minutes on average per question. If you're getting to this stage after a minute 40, you're still going to have plenty time to do that one final bit, get to the answer choice and just have a quick scan just to make sure you haven't missed anything before you move on. Please don't feel the pressure to get something down on paper, to get your first line of algebra down on paper, I don't know, after 30 seconds or a minute or something. The length of the question will dictate how long it takes you to get that first line of algebra down on paper. And if you can stay calm, figure out what's going on. We did a lot of work to figure out what on earth is going on in this question. Well, then the final steps do become a bit more simple. All right, we've got one question for you today. We're back to a data sufficiency problem, and this one's going to be a bit of a challenge. There's a fair amount of work to do in order to get to an answer here. So, as ever, give you a couple of minutes. I'll see you back here to take a look at the solution.
All right, two last things. Thank you so much for making it to the end of the video. If you've made it this far, you're one of those awesome people that's obviously really engaged in this GMAT thing. We would love your comments and your feedback. If there's anything else you'd love to see in our videos, hit us up in the comments. We'll do our best to oblige. Second thing, if you're enjoying it, hit that like button, hit the subscribe button. Helps other test takers like you find our full free video course. You need anything else? You know where to find us, gmatninja.com. Thanks so much. Enjoy this last question.
Okay, final question, and don't worry if you found this one more difficult than the rest of the questions of the video. There's a lot of moving parts going on here. There's actually quite a lot of work you need to do in order to get to a solution. So let's jump in, let's take a look at this great big wall of text and let's see where we can end up here. So we get told Brian works as a consultant, he only works for 3 companies, company A, B and C, and we get told his daily rate of 500 when he works for company A, 600 when he works for company B, and 1,000 when he works for company C. Now at this point you might be tempted to get some words down on paper, but we don't have anything we can really make an equation from. Again, one of the things we can think about when we're working with word problems is resist that temptation to dive in, put your pen to paper and just start scribbling equations or just start putting numbers down. I need to find something that I can work with. I need to sort of find something useful before I start creating equations that might not go anywhere. They might just be a waste of time. So the final sentence we get told here, Brian earned a total of $11,300 last month. That's the bit, now that's my trigger, now I can go to work. Because let's define our variables. Let's say A is the number of days he works for company A, B is the number of days he works for company B, and C is the number of days he works for company C. Then the total amount that Brian would earn in a month would be 500A plus 600B plus 1000C. And I get given a total, 11,300. So I've got something there I can make an equation from. Now I can go and use it, and we can do a little bit more with this. We can simplify. Let's divide everything by 100, and so this will end up being 5A plus 6B plus 10C is equal to 113. Still not very nice, but it's a little bit nicer than the line above. All right, the rest of this, we get told Brian worked less than 5 days for company A. So A is less than 5. And the question, the thing we want to answer, how many days did he work in total? So the question we're trying to determine whether or not we can answer is, well, what's the value of A plus B plus C? So I've got an equation, I've got a bit of an inequality, and I know what I want to answer. Let's get into statement 1 and see where this takes us. So statement 1 tells us Brian worked 8 days for company B last month. So straight away, B is equal to 8. And I can plug this into my equation and see where this takes me. So 5A plus B is now 8, so 6 times 8, that's 48, plus 10C is going to be equal to 113. Subtract 48 from both sides, and I'm going to get 5A plus 10C is equal to 65. Everything there is divisible by 5, so we get A plus 2C is equal to 13. Right now, on the surface of it, this doesn't look sufficient, but I've got this limitation here. A is less than 5, so A could really only be 4, 3, 2, 1, or 0. Brian might not have worked any days at all. And when I plug that into this, I might be able to get one and only one solution for C. We need to check this out. So if A is 4, then 2C is going to equal 13 minus 4, that's going to equal 9. 2C, if I divided that, C is not going to give me a whole number. C is the number of days that Brian worked. I need C to be a whole number here, so that's not going to give me an answer. I can't have A as 4 and C being 4.5. All right, if A is 3, then 2C is equal to 10 and C would give me 5, so that will give me a solution. If A is 2, 2C is equal to 11, that doesn't give me a solution. If A is 1, 2C is equal to 12, so C could be 6, and if A is 0, 2C is 13, and that doesn't give me a solution here. So if B is 8, then it could work that A is 3 and C is 5, or A is 1 and C is 6, and because I've got two different ways that I can make this scenario work, that's not going to be sufficient to answer the question. I can't figure out the total number of days that Brian worked, and so I can cross out A and D here. Okay, moving on to statement 2. This time Brian worked 5 days for company C last month, so C is going to be 5. Doing a very similar thing, I'm going to put C as 5 into this equation. I get 5A plus 6B plus 50 is equal to 113, and so 5A plus 6B is equal to 63. Now this time there is no number I can divide everything by there, so I can't simplify this any further. I've just got to take this on, and exactly the same way I've got to look at what happens when A is 4, 3, 2, 1, and 0. So when A is 4, 5A is going to be 20, 63 minus 20 will be 43, so that tells me 6B is equal to 43. And again, 43 doesn't divide by 6, so B is not going to give me a whole number. B is the number of days Brian worked for company B. I need that to be a whole number in order to answer the question, so that's not going to give me an answer here. When A is 3, 5A is 15, subtract 15 from 63, I get 48. I get 6B is equal to 48, so B is equal to 8. So that gives me one solution. I just need to see if anything else is going to give me a solution. When A is 2, 5A is 10, 63 minus 10 is going to be 53. So 6B is equal to 53. That's not going to give me a whole number answer for B, so that's not going to give me a solution. When A is 1, then 6B would equal 58, that's not going to give me a whole number solution. And finally, when a is 0, 6b is going to be 63, and that's not going to give me a whole number solution. So if I know that Brian worked 5 days for company C last month, so C is 5, the only way that that can be made to work is if a is 3 and b is 8. So I do get these 3 whole numbers. I could then go do 3 plus 8 plus 5. I would get the answer. And so statement 2 is sufficient to answer this question. And so the answer here is going to be B. All right, so a lot of work to do here. As I say, we're going to break down that wall of text. We're going to get one equation, one inequality that limits our number of solutions, and we're going to understand the question we're trying to answer. Then as we get into the question, it's just a case of stay calm, work through the options as efficiently as you can, understand that you need that whole number. A, B, and C have to be whole numbers because they're total number of days worked. And we'll get down here and we'll know that there's only one way of answering this. All right, that's all I've got for you today. As you can see, word problems, it's all about that. It's a skill. It's about staying calm. It's about defining your variables early. It's about sticking to those definitions, about understanding that if you're creating an equation, then the units, that has to be the same on both sides. It has to make sense. In this case, we dealt with the amount of money that Brian was going to earn in a month. And as this question showed, it's often not the best idea to just be looking for the first thing you can see and then scribbling down your paper. Wait until you've read a bit more, understand the equation you're trying to create or the inequality you're trying to create or whatever the question is asking you to do, and use that to build from there. All right, if you found this video helpful, please hit that like button, please hit that subscribe button. It really does help other people find these videos. I hope to see you at another one of our videos very soon. Thanks everyone for watching. Have a great day.